Alrighty, folks. So, piece of paper out. We're going to get into what we're going to do today. That is trig identities. Okay. I was thinking Harvey Dent from Batman. Actually, no. We'll just call this trig identities.
Nice. What word is that? Guys, I saw Miss Caliscan on a run.
There you go. Trig identities, trigonometric identities. All right. So we're going to be utilizing some identities, right? An identity in mathematics is like an equivalency statement, or kind of like, you say if two things are identical in mathematics, right, they're equivalent to one another. So we already know some identities in trigonometry. For example, we know that a tangent of x is equal to what? Sine of x over cosine of x. Okay, and then we also know then that cotangent of x is what? Cosine x over sine x, right? Okay, so we have those identities. We also have all of the reciprocal trig identities. So, for example, sine of x is 1 over cosecant x, right? Cosine x is equal to 1 over secant x, and then tangent of x is equal to 1 over cotangent x, and then of course the ones we are maybe more familiar with. Cosecant is 1 over sine of x. Secant x is 1 over cosine x, and then cotangent x equals 1 over the tangent of x. Okay, so these are all identities that we already know. Okay, trig identities we already are familiar with, which we are already familiar. And so we can use those. Bless you. Okay. There's one other group of identities we're going to look at today, introduce today, and those are the Pythagorean identities. You may have heard of these before, maybe not. I don't know. Okay. And by its name, you can probably tell that we derive them from the Pythagorean theorem. All right, so Pythagorean theorem, if you remember, it relates, well, what does the Pythagorean theorem relate? What do we relate using the Pythagorean theorem? What about a right triangle? Okay, yeah, so like leg squared plus leg squared equals hypotenuse squared are the sides. Yeah, we relate all the sides. So we're going to label this here, okay? And so we know, for example, here that a squared plus b squared equals c squared, right? Bless you, with c being the hypotenuse there, okay? You're welcome. But now, also with this being a right triangle, if I throw an angle theta in there, I can also set up another relationship too. And I can say, oh, well, with theta in there, since it's a right triangle, I can say something like sine of theta is equal to, well, what would sine of theta be equal to? What ratio of sides here? A over c. And what would cosine of theta be equal to? B over c. Okay, now, you'll see in these three relationships here that we have a lot of like crossover with our variables. So for example, sine of theta equal to A over c, we could rewrite that as c times the sine of theta equals a. Right? And likewise here, if I multiply both sides by c, I could do c times the cosine of theta equals b. And is this a not the same as this a right here? And is this b not the same as this b right there? They're the same, right? And so that a and the b in the Pythagorean theorem we could replace with the equivalent c sine theta and c cosine theta. So c sine theta squared plus c cosine theta squared equals c squared. Okay, so we just did a substitution there. Substitution of equivalent things. Again, this is not the identity itself. This is how we derive the identity. We'll see here. We're going to simplify a little bit, and then we'll get the actual identity. Okay, so c sine theta, that quantity squared, how can we simplify that? Or how can we rewrite that? C squared sine squared theta. Yep, and then this also, c squared cosine squared theta equals c squared. Okay. And how can we further simplify here? Ideas? Ramike? Square root both sides? Okay, yes, but since we have that plus in there, we won't be able to break it up. So, Julia, what do you say?
Pull out the c squared.
Factor a c squared out, GCF there. And Megan, is that what you're going to say too? Yeah. Okay, so let's factor a c squared out. We do have a GCF. Okay, like so. And then what does this now allow us to do? How can we further simplify? Divide both sides by c squared. Now, like Mr. Whitmire, you told us in the past that if we have variables, we should be very careful about dividing variables on both sides here. Okay, and so yes, we do need to be kind of a little bit careful here. But again, we are kind of like in a context. You could maybe say the hypotenuse wouldn't be 0 potentially, although I don't think the hypotenuse ever would be 0 in that right triangle there. So we don't have to worry about c being 0 and potentially dividing by 0 here. So if I divide both sides by c squared, we end up with sine squared theta plus cosine squared theta equals what? 1. And there is our identity. Okay, there's our Pythagorean identity. Okay, there are 3 versions of the Pythagorean identity. I kind of like to consider this one like the primary one, and that's just me making something up though. But that's like kind of like the primary one we use, and then from this we can derive 2 other ones. And how do we derive those other ones? Well, we take the original, and again, that's my words, not like official math words there. Okay, this is my own kind of like thinking. We take the original and divide both sides by, for example, sine squared. Okay, if you divide both sides by sine squared theta, what happens here? What does that simplify to be? 1. What's cosine squared over sine squared? Cotangent squared. What's 1 over sine squared? Cosecant squared. And there's another Pythagorean identity. And then if I take this and instead of dividing through by sine squared, I should divide through by what? Cosine squared. Okay, so all that jazz right there. What's sine squared over cosine squared? Tangent squared. Cosine squared over cosine squared? 1. What's 1 over cosine squared? Secant squared theta. So there are our 3 Pythagorean identities. Okay. Do you need to memorize all of them? I mean, if you want to, but really I always just remember the sine squared plus cosine squared theta equals 1, and then I manipulate that one to get the other 2, right? By either dividing through by cosine squared or dividing through by sine squared, one of those 2. Okay, but there they are. Yes, Ramike, question.
So you won't be given this to us on like quiz or a test?
You would not be given this, no. You'll need to remember it. Okay? Questions on any of that? All right, so we have all this knowledge now, right? We have all these identities that we kind of like, derived or, reviewed. How are we going to use them? Well, let me show you. Can I move this? Is anyone still writing?
I can copy.
All right, I can do this. How about that? We'll just do like an infinite scroll kind of thing. Okay, so we're going to use this for something like show that secant of that Greek letter that I don't know the name of. I think that's like a lowercase phi. It's not the alpha. Alpha would be like
The Jesus one.
it's close. Right. So yeah, the Jesus one would be if it was rotated 90 degrees clockwise, and that'd be an alpha. But I think that's a lowercase phi.
Where does that Jesus thing come from, anyways? It looks like a fish. Is Jesus a fish?
It has in the idea. I think the origin of it is that like. Gosh, I used to know this. It was a symbol used to represent like Jesus and like the fish, and then yeah, also being alpha kind of thing. So as well. So yeah, there is something to that. I forget not to look that
He
up.
can turn into a fish. He can shapeshift.
Maybe, I don't know.
We weren't there. We didn't see. Oh, that's
So anyway, secant of phi, I think, times sine phi over tangent theta. We want to show that that equals 1. All right. So, we want to show that this is so. All right. So essentially, we want to take this and simplify it down to be just plain old 1. All right. What might be any thoughts about maybe how to go about doing this? Right. Immediately we look at this, we're like, wow, nothing cancels. So how are we supposed to get this down to 1? What might be a good strategy to employ here to maybe try and simplify this down more than we have already? Yeah.
Maybe like take secant and make it so 1 over cosine.
Okay, because secant can be rewritten as cosine, and what else can be rewritten here that might be helpful? Yeah, tangent can also be rewritten as cosine over sine. So exactly right. So we'll rewrite the secant as 1 over cosine, leave sine, and then we'll rewrite tangent as, and you can see now why we did the warm-up, like that. Okay? And instead of dividing by sine over cosine, we'll multiply by the reciprocal, cosine phi over sine phi. Okay? And now, instead of dividing by sine over cosine, we're multiplying by cosine over sine, the reciprocal there. Now what can we do? What can cancel? The sines can cancel, because it was sine over 1, right? And what else can cancel? Cosines, right? You got a cosine in the numerator, cosine in the denominator. And what's left? 1 over 1. So it's 1 equals 1. Check, it works. Okay? So, strategy here, Ramike's suggestion was excellent, okay? Change everything in terms of sine and cosine to simplify. Okay, change everything in terms of sine and cosine to simplify here. Okay? Now, I say that, I guess we don't need that paper anymore now. Okay, let's do another one here. So this is what you would call like a verification, right? We were given something that was true, and we wanted to show that it was in fact true. We can also just be asked to do something like just simplify. Okay? You might look at this and say, well, didn't we just simplify here? Yeah, we did, but there was like something we were shooting for. We had a goal. We wanted to show that it was equal to 1. Here, for this case, right, you might just be asked, simplify, and now I'll use the fish. Cosine squared alpha, secant squared alpha minus 1. Okay? So in this case, we don't have a goal that we're shooting for. We just want to simplify this. Okay? Now, we could rewrite secant squared as what? 1 over cosine squared if we wanted to, and then work from there. So that's one option. Okay? Another option is, this looks awfully close to one of our identities we just learned. Right? So if we go back to those identities we just talked about, which one of the three, this is not going to quite work. It basically does. Which one of the three here does that secant squared alpha look like? Or could we manipulate to be? The third one here, right? In fact, it's the exact same thing if we just do what to both sides here? Right, so if we take this and say, all right, well, that means then tangent squared theta is equal to secant squared theta minus 1, which is exactly what we have right there. What is this the same as then? Tangent squared alpha in this case, right? We have a different variable. Okay. How could we further simplify this? Make tangent sine squared over, make tangent squared sine squared over cosine squared, right? Right? Tangent squared is sine squared alpha over cosine squared alpha. And what can we do now? What can simplify now? Cancel out the cosine squareds, right? So we're left with sine squared alpha. This is alpha, the Jesus fish. Yes, the fish you see on the back of people's cars and stuff like that. Okay. The Greek letter used for that symbol. Yes.
I mean, I know Jewish. Say, just because I'm Jewish doesn't mean Jesus doesn't. I mean, I guess that's good.
Okay. Yes.
So I'm just confused on where the tangent comes from secant.
So going back to our identities here. Okay. We have secant squared. You see it now? Okay. Question, Emily? From here to here. So tangent squared theta plus 1, right, is secant squared. Right? That's like the identity we came up with. Potentially, yes. I mean, again, I would suggest just memorizing this and then remembering that you can divide through by sine squared to get this, or divide this through by cosine squared to get this, if you want to. But yeah, you want to know those. Yes.
So we only have to memorize one.
I would say, and again, I would suggest memorizing this one and then just deriving the other two if you need them. Kind of thing. Yes, Mike.
Should we just memorize one and then?
For like the 3 Pythagorean identities,
No, for the trig identities, all.
the ones you mean up here,
Yeah.
you should know all of them. Yeah. Yep. You should know all of them. Yep. Okay. Faux show. Now, I mentioned earlier, about changing this to be in terms of sine and cosine. So let me do that here real quick and just show you what I'm saying. So one other option we had here was do cosine squared alpha, make that secant squared 1 over cosine squared alpha. Okay, so if we did it this way, the other option that we kind of had here, what would we do now to simplify this? We could distribute, right? We have cosine squared in front of parentheses, so distribute it. What's cosine squared times 1 over cosine squared going to give us? 1, right? And then cosine squared times minus 1 is going to be minus cosine squared alpha. Okay? Now, what's 1 minus cosine squared alpha? Well, if you look at that, that kind of looks like our first Pythagorean identity, right? We can manipulate this to get 1 minus cosine squared, right? For example, if I take this identity here and I subtract a cosine squared over, I have sine squared theta equals 1 minus the cosine squared theta. Right? Is that not the same as this? It's saying the same thing, just manipulate it algebraically. And so 1 minus cosine squared is sine squared. 1 minus cosine squared is sine squared alpha. Okay? So there's sometimes more than one path to take to get to these results here. Okay? Kind of have some options. All right? On Friday, not a bad thing. Questions on any of this? All right, let me give you guys one to try then here. So this is for you. I want you to verify that secant squared x times 1 minus the sine squared of x is equal to 1. Okay? Show that is true. Now, since we're trying to verify, one little note here. Since we're trying to verify that this equation is true, what you should not do is any sort of algebraic maneuvers where you're like adding the same thing to both sides, subtracting the same thing to both sides, multiplying or dividing the same thing to both sides. You should not do that because that assumes the things are already equal. Okay? So in proving two things are equal, you should not then use an assumption that they are equal, right? It's kind of putting the cart before the horse there. So instead, you need to kind of like work with one side, this side, manipulate it down so that you do see that it equals 1. Okay? That's the idea. So give that a try. We're kind of coming around to help. That's the bathroom? Yeah. So, how can you manipulate this around to simplify down to 1? Good question. How can you manipulate it around to simplify down to just 1? No, I gotta save up. Well, because this week is snack week, and so like they gave us so much snacks.
Oh, and you gotta get ready for prom.
I gotta save up room because we're gonna have barbecue for lunch
Today?
today. Carter Q. So I'm super excited. It's gonna be in the cafeteria, and I can save some room for that.
Oh, you're right. So
Wait,
one
just
for
drop
the
it.
Oh, yeah.
You can rally.
Yeah.
Actually, my favorite is like.
That's what they do in the Hunger Games, isn't it? The people in District 1.
Oh,
They would make themselves sick so that way they could eat more, party harder. I think they did it in real life and like,
the capital.
yeah, in the capital. I mean, sorry, yeah,
That is District 1, I thought. No, it's just
that's just the capital.
Sorry.
So, bless you. And I think people did it in real life, like cultures that did it, like in maybe Greece or Rome or something like that. Where they have those crazy parties. Yes, it's a great movie.
I love that movie.
Also, yeah, I enjoy it.
It's really stupid, but it's fun.
I mean, it's Trey Parker and Matt Stone, so South Park guys.
My favorite part is when they're talking about Matt Damon and they go,
Matt Damon. Yeah.
I don't know. Is it on Netflix? Probably not.
It used to be, but I don't think it
You're
is.
the reason it's
Yeah, you know, things go on and
No,
off,
wait,
so.
Thomas Whitmer was a teacher. Just you didn't know that I illegally watched it.
Yeah, I was just reading it. And I was like, yeah.
And then watch the viruses pour into your computer.
It's on my phone, so it's not that bad.
Pour into your phone. And
No, because you just have, because
It's like worth it.
oh, that's all you gotta do.
Also, just be completely ignorant and it won't happen.
Ignorance is bliss, yes.
That's true. If you don't see it, it doesn't see you. You know?
Yes.
Like if you close your eyes until the movie starts,
Yeah.
no virus. Yeah. It's like extra bad. No virus. Yeah, actually, it's pretty fun. I'm not scared of it. Just frightened by it. Not scared. Just scared. I did. I put a Band-Aid over my computer. The government is watching. Shut it.
Okay.
It's terrifying.
Anyone still need more time? Nay?
And say,
All right, let's see what we've got here. Yes, go ahead. All right, how about then? Well, Hayden, you got an answer for us here?
That's a hate crime, no.
That's a hate crime? No. All right. Andrea, were you able to do something here?
Yeah.
Okay, what did you do?
So I manipulated the first identity we got from Pythagorean thing into 1 minus sine squared of x equals cosine squared of x.
Okay, so we can replace that 1 minus sine squared with a cosine squared. And did you rewrite the secant squared at all?
Yeah, I rewrote it into 1 over cosine squared of x.
Okay.
And then you multiply it out, and cosine squared of x over cosine squared of x does equal 1.
Yeah, and so we get 1 equals 1. Check. Okay. Anyone do it differently than that? We all did it the same way or didn't do it at all? Or you just don't want to volunteer because you don't feel like saying what that different way was? I got you. All right, so anyway, the other alternative here, I'm going to say it anyway. The other alternative is you could distribute the secant squared, okay? Secant squared times 1 would be secant squared x. And then sine squared times secant squared gives you 1. So you'd have secant squared minus 1, which is, again, a manipulation of that Pythagorean identity. Okay. I feel like I messed up. No. It would be secant squared minus tangent squared. There you go. And so then secant squared, take away the tangent squared over there, you get the 1, just like that. Okay, it would work. So, there it is. Questions on any of that? Yes?
If you like manipulate the problem into one of the Pythagorean identities, is that answering the question, or do you have to make it equal to 1?
It needs to be equal to 1. Yeah. So if the directions say just simplify, then you just like do as much as you can, try and like condense it down to a single term, whatever. But for verify, your goal is this. You've got to get it equal to 1. And in this case, other verifications will be different things you're equal to there. And typically you take the left-hand side and manipulate it to look like the right-hand side kind of thing. Typically what you do. Okay. All right. If there are no questions, then that's all I've got for you, okay? We're going to get you guys started on your assignment. All right, there is homework tonight. I'm going to put it up on the board.
Like and subscribe.
Like and subscribe. Smash that subscribe button.
Yes.
Leave a
Turn on
comment.
post notifications.
Leave a comment in the comment
And I'll
section
follow
down below.
back. I follow back you, turn on post notifications. Check out my merch.
Yeah. If you want to see more videos like this, check out my Patreon page. Support me.
Please support our growing family.
And if you'd like me to send money to my PayPal.
Yeah, right, yeah.
Send things to my P.O. box. I'll do a
My
little
address
review.
is 6.
I'll do a little review on my YouTube channel of fan mail.
If you'd like to stalk me, I'd be very flattered.
There's your homework.
Young boy, young pineapple boy on Instagram.
It's all.
I work
Yeah,
at
25,
Robotics
26, 27, all
And
4.
if you'd like to murder me, I'd be
And I have a green wing macaw.
Green wing macaw.
Green wing macaw, baby. It's what it's all about. Green, but it's red. When it's green, but it's also it's red. Honestly, I just like but you're green. Like, yeah,